Hi there, I'm Evan Troxel. Welcome to my podcast about how technology is changing the architectural profession. Welcome back to the podcast. My name is Evan Troxel, and this is officially the last episode of 2020, which is, of course, my Holiday Spectacular episode, and I couldn't be more excited about it. My guest this week is Brian Ringley. Brian is the construction technology manager at Boston Dynamics, and he works very closely with construction customers that use the Spot robot. You've probably seen Spot if you've gone to a conference, definitely online. It's the yellow four-legged robot that everybody is scared to death of and also thinks is very, very cute. So a bit of a warning, this is going to be the longest episode intro of the year because there are so many things we did not have the opportunity to get into this holiday spectacular. So before we get to the conversation, there's actually a couple of things that have recently happened in the Boston Dynamics world since we recorded this conversation. So first off, some very interesting news hit the internet this last week in which Hyundai is officially purchasing a controlling stake in Boston Dynamics. That stake is at about 80%. They're buying it from SoftBank in a deal that values Boston Dynamics at about $1.1 billion. Hyundai says that this investment will help its development of service and logistics robots, but that over time it hopes to build more humanoid robots for jobs like caregiving for patients at hospitals. Other areas of interest include autonomous driving and smart factories. And just for a little bit of history, previous to SoftBank, Boston Dynamics was under the Google umbrella. So what started out at MIT, went through Google, SoftBank, now at Hyundai, which is really interesting. Number two interesting thing that happened since we've recorded this episode was that Brian wrote an article over at Architect Magazine, which I've linked to in the show notes along with that Boston Dynamics announcement, and it is well worth reading. I would like to spend a few minutes right now on the article to provide some context and insight surrounding our conversation that you're about to listen to. So the article is titled Beyond the Master Builder, How Robots Can Really Transform the Role of the Architect. And like I said, Brian wrote this article and he sees invaluable opportunities for robotics that have little to do with automating building construction and installation. In the article, he begins with a few salient quotes, and I'm going to kind of rattle some off here real quick, again, just to provide some context for what we eventually get to in the conversation. Automation and robotics already exist within the discipline, but they have manifested differently than what people typically envision. Another point is that BIM has failed to empower architects with significant control over the building delivery process, and building information modeling has been steadily automating aspects of architectural design for years. Despite its impact on daily design and documentation tasks, BIM has failed to empower architects with significant control over the building delivery process. The conversation from which architects should not want to be excluded then becomes, how can we more effectively apply automation and robotic technologies that exist today in a transformative manner for project delivery and revenue generation? He then goes on to talk about the fixation on returning to the ideal of the, quote, master builder and the problems baked into that way of thinking. So once again, I'm just going to pull a few of my highlighted things from the article that I thought really drove that point home. First, architects, or some subset of them, have a fixation for the direct control of construction tasks, bypassing tradespeople as a means to reclaim, quote, craftsmanship. I think that is really interesting. He explains that the rather obvious infeasibility of implementing this approach in today's risk-averse and siloed design bid-build delivery model, and that the AIA contracts strictly prohibit architects from engaging in means and methods. To finish up this section about the mythos of the master builder, Brian states that model-driven delivery methods are premised on the notion that the intelligence required for the delivery of a building is holistically contained within the design model, when in fact much of the intelligence required for construction of a building comes from the tradespeople on site. Pretty hard to bypass that, right? So if you've ever built anything yourself, you know this is in fact a rather large truth bomb that Brian just dropped in that article. And that's just the beginning. He gets into how agile mobile robotics, which he says are the missing piece in an automated field data tech stack, can actually help bridge the data and communication gaps between the siloed disciplines we find ourselves operating within by our own willingness and doing. Overall, this article is a great gut check laying out the inviolable, look it up, requirements that set forth, with our guidance and involvement, an aversion to risk that we must now deal with at a very structural level within our profession. And finally, here's a pointed quote about using this technology as a compelling opportunity to leverage expertise and have it go beyond one project just for good measure. Brian says, quote, "All too often, architects, in a fugue of deadline-induced haste, contractual impotence, slim margins, and the manifold layers of real estate market abstraction from end tenants, move from project to project with no real sense of whether their product works. As a result, they gain no insight to apply to the next product iteration," unquote. So this is arguably what on-site agile mobile robotics can help accomplish by bridging the gap between architects and tradespeople to gain that which they lack, which is insight. This episode is a fantastic conversation about how Brian got where he is and became who he is. We talked about the ability to, in true Steve Jobs fashion, easily have the ability to connect the dots looking backward when in fact no one could then have predicted the outcomes we now see. And if you follow Brian on Twitter, you know his dry humor and comedic tendencies, and you also know he's, dare I say, a true treasure of our profession. That's for you, Brian. I mean that. I couldn't think of a better guest for the first TRXL Holiday Spectacular, so without further ado, I hope you enjoy my conversation with Brian Ringley of Boston Robotics. How you doing?
Oh, good. Really, really busy and frantic, but good. Yeah. How about you?
Similar, I think. Trying to find moments of the day for peace is hard. I appreciate you taking the time today. I don't really know what this holiday spectacular is going to lead to. I do have a fresh cup of coffee. Like maybe it doesn't get any more spectacular than that.
Also, check out this coffee cup.
That's rad.
Yeah.
Is that an Apple II GS?
It looks like one, but it's clearly like somebody had their own like computer business that was called Digitals, which I love.
That's his name.
Belongs to Digital.
That's
Digital's
his name.
Personal computers.
Digital. Yeah. I
Digital.
love that guy.
Good garage sale find.
Yeah, I love how much like space there is between the 10 key and those other, there's a lot. That's a wide keyboard.
It is a stretched image for sure.
That's awesome.
I was trying to remember. I was like, were computers that long? They were pretty like deep. Don't fully remember.
That is a great garage sale find, man. That's awesome. Yeah, my mug just here's mine. And what sucks is like because I'm right-handed, all you see is this stupid Starbucks logo. But there is a nice Vespa on the other side, so I must drink left-handed.
That's true. Do they favor? Is the idea that the graphic on the mug favors like facing the person drinking from it?
Yeah, this is pre-COVID, right? Like I'm enjoying this cup of coffee, but now like now that we're on camera all the time, like you must see what like my brand affiliations or.
That's right.
Or whatnot. Yeah. It's all about being an influencer with these brands, my coffee mug brands.
Yeah, when is coffee mug art going to catch up with the era of Zoom?
Yeah. Yeah, there does need to be I need a multicam setup here so that I can quickly switch and even go slow-mo on the fly, right? So you can see like it's like a real commercial, right? When they're eating cereal off the spoon and it's like in 120 frames a second. We need that ability here. I'm trying to push my firm into like going beyond just this 15-inch screen and like think about what else you can do with a production. So I think we're onto something here with this.
Yeah, you should have a few spots walking around filming you at all times. Maybe a drone swarm.
I do need like a drone swarm in the background with a light display that fully animated. Yeah, that would be. This is a podcast all about ideas, but that's where it ends. We're just
even bad ones.
I'm just the idea guy. Like you're gonna have to run with that. I think the first time that I went to one of was like an AU class that. Oh
my goodness!
You had one of those slides on the screen that had all the diagonal lines connecting all the tools together, right? Like it was this spider web of how to get it. It was the topic that will not die, interoperability, right?
Yeah, I know. It's the state of the art forever.
Yeah. Yeah. And I mean, it's hilarious because like at one point I put together this cheat sheet of, how to get files from one app to another. And that was obviously not interoperability. That's just file exchange. And and that was a very popular document for quite a while. But that was also like, the files are dead. You must reload the files or delete and re-import.
Yeah, I love it's like such a kind of like annoyance and persisting problem in the industry. And then like the one company that kind of latched onto that and made a fully featured product for it promptly,
Disappeared.
Yeah. So clearly not an actual business need, just a nice to have.
Yeah. It's like,
and something we love to talk about.
It's like, wait,
ad nauseum.
I'm pretty sure this is the thing that all you care about. And now you're telling me you don't want it because you're not willing to buy it? That was interesting.
If you could get your file from Rhino into Revit more quickly, we would solve all of the business problems of architecture.
Yeah, right.
Turns out that might not be true.
Now we just sit here quietly. Crickets. Yeah. Oh my God.
Yeah, and there are also like some really good tools out there that do that for free or next to free. And guess what? There's at least one person in every, large enough firm who could build something like that for you. So yeah, the value proposition kind of goes out the window.
Yeah.
It's a classic example of focusing or being distracted by technology problems, which don't really seem to be at the root of what ails, architectural practice, at least from a business standpoint.
Yeah, I think you, in one of the interviews that you've done recently, where you said that, turns out automating drawing sets, the building of drawing sets from a 3D model isn't going to solve your business problems.
Yeah.
That's not a new business model. That's just the same business model. You actually have to go way beyond that.
I mean, it's a much needed automation of a task, but
right.
It's not a fundamental rethinking of delivery. That's for sure.
Well, Brian, welcome to the podcast.
Oh yeah, are we doing the podcast?
Let's call it the podcast. And so it's great to have you here. And I think that the stuff that you're talking about is the things that a lot of, well, let's not say a lot. Let's say a percentage of people are thinking about in their firms, but maybe we can go back. I think your path is extremely interesting. And I think a lot of people kind of, and this is just me speculating, but I think a lot of people live vicariously through the work that you've done because they see where you've gone, where you've come from, where you've gone to now at Boston Dynamics. And it's like how it's easy to connect the dots going backwards. It's really difficult to connect the dots going forward. Right. So maybe that would be an interesting story maybe to start with.
Yeah. I mean, it's easy to try to post rationalize and say that I, planned this, but
mastermind
and find the common threads, which there are a few, but it was pretty organic. I was educated as an architect. I wanted to be a designer. I liked technology and was familiar with it, of course, as part of the education, but it wasn't a big part of how I conceived of doing the work. But the recession hit when I graduated, so I needed to find something else to do other than go into practice. That's what got me started in academic labs and teaching.
So real quick, you got an MArch, right? So what did you do? What did you do before that?
Before the MArch?
Yeah.
Oh, nothing.
Okay. Went straight to a master's degree.
Obligatory cat appearance, by the way.
Nice.
That's going to be happening on and off.
Yeah. Well, and this, so you know, this won't be video shared, so you'll have to make a cat sound now.
Okay. He's pretty talkative. We'll see.
All right.
If we can get some audio. I should have mic'd him.
Yeah.
But yeah, so when I went into architecture school, I went into an architecture program in undergrad at Cincinnati.
Okay.
And, my idea at the time was like, I just want to get into professional practice as quickly as I can. So I'm going to do my undergrad and my graduate degree kind of all in one run.
Okay.
I did it all in 6 years. I guess I was like, it's like you're in a hurry to die, I guess, and not enjoy the moment. It was not very Buddhist. But that was the mentality at the time. So I went to Cincinnati for undergrad and then got a really nice, for being rejected by all the Ivy League schools I wanted to go to. I got a really nice package at Cincinnati where I actually got to work in what was called the Rapid Prototyping Lab at their design school. And I really kind of lucked out in a couple ways. One is I had amazing studio professors. It was an era where we had like a visiting professor program. So I had like Carl Dobman and Craig Borum from Taubman. I had Aaron Betsky, and we like helped brainstorm for the Biennale that year in Venice. So it was a really great time to be in the school, and I think it's a great school. But I had this opportunity to work in the Rapid Prototyping Lab, which was like a college-wide facility. But at the time, there weren't really a lot of architects or interior design students accessing it. It had really been established in the early 90s for automotive design and product design, which was a fantastic education in terms of like product design, prototyping, and design for manufacturing. So most of the time I was like, prototyping like electric bicycles and like cars and power tools and things like that. It wasn't very architectural per se.
Was the architecture program still really dependent on like the wood shop at that point? Or was
Yes.
it 3D printing? And
I mean, the architecture program at that point was like discovering the laser cutter and some piecemeal 3D printing, but it wasn't particularly emphasized. Some of the instructors kind of saw the importance of tying that in. I mean, making was important. That wasn't lost on anyone, but a case in point, like I had wanted to learn Maya when I was in grad school, and there were no courses for it at the time, really. So I was like taking courses, again, an advantage of being in a multidisciplinary program. I was taking courses in the digital design program, with now looking back, some professor giving me their free time, which is amazing.
Yeah.
So I got to like learn other disciplines and kind of figure out how to tie that back into like an architectural design and delivery process, and was definitely talking with architecture and interior design faculty and even urban design while I was working in the lab as a student, just because it was like, hey, why not bring architecture students in here? So when I was in a studio with Carl and Craig, who, were jointly at Ply at the time, they were like, wow, you have this incredible facility with all of these CNC machines. Like, we're going to use that, and we're going to digitally fabricate molds for the purposes of, a hypothetical refurbishment of a building in Detroit. So that was super cool, and that kind of opened my eyes. And there was this kind of aha moment, because I was looking at some of the work at some other Michigan professors, and Glenn Wilcox in particular had put out a series of tutorials for how to extract, isocurves and other curvature from Rhino surfaces and use those to directly drive a CNC machine. And I was kind of looking at that in the context of this studio work, and that was like an aha moment. Like, that was my original, like, oh, you can use a machine to drive some act of making. And that's really powerful because I design in a model. So if I design in a model and I can use that model information to directly control the way that my design is produced in the real world, that's a really powerful idea.
Yeah. We had a 3-axis CNC machine at this one interior architecture firm that I worked at. And I never was, it was always a handoff from like the design, which is where I worked, to the people who made all the tool paths, and then it went down to the floor. But we did it all in one facility, but it was very much like a handoff from one to the other. It sounds like you were pretty interested in that, the transformation of the design intent into what drove the machine. Like, so, because you wanted to learn how to do that.
I was, and I think that's kind of the thread that binds a lot of my career. I have a lot of serious questions about that mentality. I'm actually working on an article about that right now where I question some of the intent there. But before we jump cut to that, I mean, it was an interesting moment. And, I had, first of all, there were kind of a few things, again, like it was an organic evolution. Like, I was doing an internship with Francois Roche in Paris, your classic, like, unpaid graduate internship at some like radical boutique firm. But it was an interesting experience because I had this idea that it was this very like kind of techno centric design process based on the work I had seen exhibited of their practice. And it was actually this really bizarre kind of hybrid workflow. Like, there was a lot of clay sculpting I actually think the basement of this firm was a former sweatshop, which was very appropriate for
Yeah.
myself and the other European
Turns out
interns
it
down
still
there.
was. Yeah.
Yeah, I think it was like me and like three interns from like Aarhus or something. But we were, doing a lot of like clay sculpting to get like that right kind of, I don't know, almost like grotesque or handcrafted or look. It was, and then running that through, digitizing processes. So we were using like a CMM and collecting points. So you basically like model
Yeah.
something in clay, and then you
Hmm.
use like an X-Acto knife or thin tape, and you trace the ISO curves and figure out how like the topology of this thing you made with your hand would become a NURB surface. You'd basically digitize that in point by point, span those with ISO curves, create your surfaces, and recreate your surfaces like 10,000 times until they're
Yeah.
nice and like milky smooth. And then at the time, Francois was working with Mark Fornes, who is a very like prolific kind of like scripter and architect and installation artist. And then like he would send scripts back and forth. This was like VB.NET era for Rhino script, and we would populate these surfaces with different skins. And then inevitably it would look too much like scripted work. And then we'd make the skins by hand and then bring it. So it was this really interesting education in kind of understanding the mixing of handcraft and the digital, something now that I think we would probably like loosely call like post digital craft in a lot of graduate schools. But I did it first in Paris. Just kidding. Um, but it's not a super new idea. And I took that back. The reason I brought up that internship is because we hit vacances, which is when no one in France works the entire month of August. And I was like, well, I'm not making any money here, that's for sure. And I probably shouldn't spend too much more of my federal loan money in Europe. So I went back to Cincinnati early and asked if I could start my work at the RPC earlier. And the reason why this was pivotal was because it was the only time I was working 40 hours a week doing the CNC work. So I really became like a CNC programmer
This
and
is
a
your
CNC
10,000 hours, right?
machinist.
Yeah.
Yeah, exactly.
Yeah.
Like, and there were scary moments like snapping tools and
Oh,
breaking
yeah.
machines and things like that. But, I was really able to immerse myself in what was a very professionally run machine shop. It wasn't a usual academic lab where the students do the work. Like
Uh-huh.
we were professionals who did the work for the students
You
based
were
off
a
their
service
designs.
bureau. Yeah.
Hmm.
Okay.
And, that combined with what I had experienced with the studio with Michigan, and then the kind of revelation of Glenn Wilcox, I started teaching myself. So when it became clear that I wasn't going to get a job in practice, I was like, can I continue to work in this lab, but can I be kind of a liaison for getting the architecture, interior design, or urban design programs in here, which I did. I was able to make that job, and it led to all sorts of other cool things. Like I got the engineering program in there. We started working with like fashion design and graphic design. I mean, it truly became multidisciplinary and really remains that way today through the efforts of, the manager, Scott Lincoln, and the rest of the staff there, and Anton Harfman, who was the dean at the time. Everyone really bought in to that vision, which was like, this is a world-class resource. It should be, a place to share ideas amongst all of the design disciplines. And so I was working there doing that job, and I was also picking up some seminars, and I was teaching this like hilarious class where we were like painstakingly extracting ISO curves manually in Rhino, and like it was bizarre. There are probably some old tutorials somewhere on the internet, but it was like
The
it was
internet
very
does not forget.
laborious
Yeah.
for digital work. And there was a lecture by Future Cities Lab, and Natalie Gattegno, who's an architect and educator, actually did a personal like review of my course, which is awesome. It's always cool to get like the critique of the critique. And she was like, "Why aren't you using?" I believe her word was like parametricize or something, but just basically, why aren't you using parametric design or what we'd call like design
You were
computation
like,
now?
what?
Yeah, and I was like, oh, because I had used Grasshopper like briefly when it first came out in 2008 as explicit history when I was in Paris, actually, and I was like, this is horrible. There weren't even data trees yet. Blah blah blah. This looks hard, right? It's the same way I
Yeah,
felt
right.
when I opened Revit or Generative Components or all these or Maya, where I was just like, oh boy, this is gonna be terrible. But but she said that, and I was like, okay, point taken. And then the students started a petition which is kind of awesome, demanding that someone in the design school teach Grasshopper.
Wow.
And then I don't remember who, like the head of the graduate program or something, came to me and was like, well, you're, to paraphrase, well, you're the young, low-paid adjunct, like who knows about computers, so you do this. So
Wow.
I was like, okay. So I taught myself Grasshopper in a coffee shop on Main Street in downtown Cincinnati every night after work. I was really bad at it for probably a good 2 years. Even when I was first teaching it, I was so bad at it. But that's how it goes. So we started using those methods to all right, now we can have this be rule driven and parameter driven. We can actually take this a lot further, introduce, eventually when I started teaching at Pratt, we'd introduce actual data, like let's run a structural analysis or environmental analysis and use that data to kind of drive what we're doing with manufacturing operations. But at the time it was purely ornamental. The dean of DAP, I think Robert Probst at the time, may still be dean. I don't know if he's doing right now. Actually bought one of the pieces off the students. So that's a point of pride for me as they're selling their work. But created these really beautiful 4 foot by 4 foot by 6 inch thick glued up Baltic birch pieces with our incredible Como CNC router in the basement, which is a 5 foot by 10 foot by 2 foot deep router. It was awesome.
Yeah.
And ran those seminars for a few years, and that's kind of when I first connected, not just oh, I can use the digital model, but also I can leverage something we'd now call, we have words for all these things now. We now call computational fabrication, which is to use those design computation methods to create a kind of more direct relationship between the model and the manufacturing. And then, as I said, by the time I got to Pratt and had learned a bit more through my teaching at CUNY as well, how do you actually get some analysis into that so that your work was performing in some way, right? You could kind of measure the success of what you manufactured.
So let's pause there for a second. I want to go down this little rabbit hole first and nerd out for a second, because you're such a curious person. You obviously weren't satisfied with the tools that they were talking about in the architecture department. You were interested in Maya. Maya is a visual effects piece of software. It's all kind of always has been. Subdivision surface modeling for the most part. You were able to bridge the gap of the vocabulary for one, but the concepts for two, because you went that route. Because when you're using subdivision surfaces, it's all about topology, and you're retopologizing all the time because you want to get the surface to do what you want it to do. And it's all about those quads. It's all about kind of going through and redesigning it so that the surface works. And so then, obviously, translating that into NURBS, getting into the organic side of things, which is very much not what we were taught in the 90s in school. There was no, you rarely saw anything organic at that time still. It seems to me because of your curiosity in these and going outside of the traditional toolbox of architecture. I remember going to SIGGRAPH in the 90s and seeing Bob and Scott at the Rhino booth, which was 2 guys and a table. It was nothing, right? and they were showing car fenders, right, in the software with the zebra stripes on them, showing the continuity of the surface. And it was yeah. And I'm an architect. I'm that's cool, but I'm going to go to the Form Z booth, right? It was very, it was another world. It was very much auto and boats and things like that in the Rhino world back then. But it's interesting to see
Form
now.
Z had the stair tool.
Yes, Form Z had a couple of architectural tools.
And the system beep.
Right. So, because of that curiosity that you had, I mean, Rhino wasn't in the toolbox back then. Grasshopper most definitely wasn't in the toolbox, right? It just didn't. It wasn't there. And then you didn't have. You had the Maya, which was not in the toolbox, and you're then going kind of reverse, going back through the machine, and ultimately this all kind of leads back to architecture and even now where you are with robotics. But man, what a crazy journey. And I think it's only through that curiosity that you actually start to make these really weird connections and opportunities.
Yeah. And, not to spend the entire podcast talking about my college years, but
that was the weird, agenda item number one.
Yeah, the weird thing about that was I had actually been using Rhino before college. So purely coincidentally, like I went to an okay school. I went to a school called Ontario High School in like Mansfield, Ohio, graduating class of like 144, very like small farm school. But they had a very like kind of vocation heavy curriculum, which included like drafting and 3D modeling and carpentry. And just by virtue of the teacher Bruce Wyrick being involved with Rhino somehow early on, like our high school was like a regional like Rhino training center for other people
Wow.
who wanted to teach Rhino. So I had used Rhino since I was 14. I've used it since I was 14 years old.
That's amazing.
And that means that now I've used it a lot longer than I haven't across the course of my life at this point. So I am at least 28.
Yep.
There's your clue.
Yep.
And so I got to architecture school, and at the time it was just like, yeah, whatever, this is 3D modeling software, and I learned it, cool. And then I go to college and I'm like, I'm ready to learn architecture software. And that was presented to me as Form Z on a MacBook, which is like, what a weird combination.
Yep.
With a physical license dongle and the aforementioned system beep. I just remember being in the lab with all of us modeling in Form Z, and you
All the
just hear,
beeps.
like, boop,
Yep.
boop,
So
boop.
many beeps.
You also had to like click like 3 buttons to do anything. Could
Yeah.
write a paper on like the weirdness of that software, which is very popular. And I just thought that was architecture software. I was like, okay, this is what architects do. I didn't know any better. And then like by junior year, I was like, you know what? I think I'm gonna start using Rhino again. Like, and also I think I'm gonna start using Windows again. And like, just because I was educated with these work sets doesn't mean that this is like the only way to think about how to design and model. But then, to some of the points you're making, it over time, it was important to me to learn a lot of different types of software, like poly modeling or sub D modeling or NURBS modeling, to understand, what are the kind of like topologic methods there, like in terms of, but like what data do the surfaces contain? I was really interested in the work of Greg Lynn at the time, who was like, all about those NURBS. And, a lot of his work was like, there's a ton of embedded information in a mathematically defined surface. And how does that make us think differently about the surfaces we produce in the physical world? How do we embed information both in the kind of digital design model as well as the physical result, and also leverage digital fabrication to kind of connect the two? And one of the, let's see, Michael McInturf had worked with Greg Lynn on the oh my gosh, Church in Queens, like the Korean Church in Queens, which is like a seminal like blob building. And then Michael McInturf was teaching at Cincinnati along with Greg Lewis, and they were both offering this. There was one Maya course, and they would teach this kind of like how to design and produce form through animation. And then we would like 3D print it, because the nice thing about like a poly model is if you start with like a watertight manifold primitive, if you don't go too crazy, it's going to stay watertight. And
Right.
it lends itself well to additive in the same way that a NURB surface with the ISO curve information lends itself really well to driving highly precise CNC machining operations. So for me, it was important to be like, oh, okay, like these different modeling types have different affordances in terms of how that data can be communicated downstream to some means of production.
Which is very different than drawings, right? Like that to me is super interesting, because you're talking about the stuff that Greg Lynn is talking about, like what's embedded in the surface. How does that make us think differently about the surface? Knowing that, you want to fabricate that surface is very different than the information you would put into two-dimensional drawings as an architect typically thinks. And therefore you model differently because of the outcome, which people still have a really hard time kind of wrapping their heads around, whether it's 3D printing or CNC or whatever. Yeah.
And I have a very perverse relationship to all of these things. I have this conversation a lot with Andrew Human, who I've worked with at a couple places, and I think you've interviewed him, right?
Yep.
Yeah. I definitely listened to that one. I promise.
Yeah, Andrew's listening, and he's listening to this one, right? So
better. Yeah. So we've had a lot of talks about this. Like, what does it really mean to draw? Because we do tend to create this with all due respect to, people who are good at drawing, people who think they're drawing, people who think they're modeling, blah, blah, blah. It has to do with this kind of how quickly something can move from your brain to manifest itself somewhere. And, the intermediary device of a mouse or a keyboard or even a screen can, of course, stunt that. But it doesn't really have to be that way. There can be an immediacy to a digital native, I think, to thinking through Rhino. So again, I was a weirdo. I hated drawing. I painstakingly learned how to like shade a drawing that looked like fairly realistic of a person freshman year, and then said, okay, cool, check. I never want to do that again. I had lots of friends. I mean, like, I had a colleague named, Brett Albert, like, who's an incredibly talented drawer and painter who went to school with me, went on to the GSD, was an animator for Walt Disney. I was exposed to that, but I was just never particularly good at it. But I had been modeling in NURBS since I was like 14. So like that just made more sense to me. So I was always sketching in Rhino. The first thing I'd do if I had a design idea was like think about it in 3-dimensional space. Think about it like in terms of like a perspectival like viewport that I'm spinning around. And I would do all of my sketching and all of my work in there. I had a really interesting studio at one point in grad school taught by, was it grad school? Undergrad, doesn't matter. Taught by Carl Wallach. And he actually did a really interesting thing where we were allowed to neither draw nor model. And we spent the entire semester only physically modeling a project, basically like 8 feet in scale at a time.
Wow.
Which was a fascinating way to work and completely kind of like re-geared my mind. So there's absolutely something to the medium, right? And the outcomes are all the same. Ostensibly, you're trying to build a building. I guess that's arguable.
A real thing, maybe, yeah.
Yeah, I was hoping to at some point. So that was great to kind of balance out, this experience I mentioned with Francois Roche about kind of like hybrid media and this kind of like fluid mixture of the kind of handcraft and hand manipulation with digital methods, both input and output. And then this experience where it's just like, you're not even allowed to draw. Like you weren't allowed to sketch. You were allowed to mark with your pencil on the basswood, so you knew where to cut it. That was the difference. So that was a really good experience too. And I think it definitely applies to this idea of, when you're in a different medium, you kind of approach it differently. And for me, that was about, again, the affordances of downstream digital fabrication and this design for manufacturing approach I had kind of adopted from my work with industrial and transportation design students.
I would think at some point there, like going through that course specifically, it's about kind of how you put things together, right? And because if you're building something for real, it's not made out of one big part that you're either adding. It's not additive. It's not subtractive. For the most part, it's like taking these parts and putting them together in some way, fastening them in some way, whether that's, a model the size of your hands that you're using glue, or if you're using screws and nails and whatever, slots and tabs and, it just depends. But I would think that like, that's the kind of connection that most architects actually need to make so that they understand the purpose behind the thing that they're modeling on the screen, even if it's for a machine to read at some point. Somebody or something has to put that together.
Yeah, which this is why like I thought sub-D modeling was really great when I was a student, and then it was like the bane of my existence when I was rationalizing facades at Woods Bagot, which was like, this does not lend itself to rationalization for the constructed environment, knowing what I know about building assembly. But specific with that studio was really fun too, because if you just immerse yourself in kind of one medium for a while too, you try to like take it to its extremes. It's also worth mentioning that I think 4 of us had to go to the emergency room at some point for an X-Acto knife wound.
3 a.m.
Yeah, mine is a scar on my thumb. I did have I almost said colleague. What's it called? Fellow student who was cutting toward themselves. Malcolm Lee, I'm going to name him by name, and stabbed himself in the stomach because he was cutting toward himself. Yeah. So we also
Not
all
a Boy
used
Scout.
Zappa. Listen, it was probably 4 a.m. Right?
Yeah.
Is unhealthy environment, I'm I'm afraid. But speaking of unhealthy, also like tectonics wise, and yes, there was the pleasure of detail, but there was also copious amounts of Zap-A-Gap and Zip Kicker, because who has the time to wait for Zap-A-Gap to set?
Nope.
Also, so many chemical burns and gluing things to yourself.
Yeah.
But it took us to interesting material extremes too. I mean, one was like, all right, when does it make sense to model the joint, and when does it make sense to etch it? And again, we didn't have free access to the laser cutter at the time, and our professor didn't really like the burning of the laser cutter, and without going down a rabbit hole of how to mask and avoid that in the craft of laser cutting, we were hand etching patterns with our X-Acto knives. And I remember discovering corrugated basswood by going to a local doll shop or dollhouse shop. So they sell corrugated basswood, so you can paint it white and use it as like the roof for your dollhouse.
Oh, okay.
And we found that in the architecture school, just like,
boom.
We all just met at this dollhouse store and, bought them out of their corrugated basswood supply.
Solidified I also went down their business plan for that year.
Yeah, probably. Hopefully. I mean, it was a great shop. I hope it's still in business. And then we also went down into the valley to like a plumbing supply shop. I got this huge sheet of lead. And lead is like such a pleasure to work with.
Isn't it? It's really satisfying.
Like,
yeah.
Cuts like butter. And I was like, this is my water. Like, because you also have to one up everybody else. It's like, you're going to do plexi, and you're going to do like soft blue paper under plexi, and like I'm going to do lead, and I'm going to polish the lead. It's super shiny. But here's the thing about that: I knew it was toxic, and I used gloves, but no one else did. So every morning I'd come in, and there'd be fingerprints all over my water feature, and I was like, uh-oh, like I'm poisoning my colleagues.
Oh man!
But I digress.
Yeah. So many secrets being revealed here.
Yeah.
Okay, so that's the school years, and then like you actually get out into the profession, and it's not normal, right? Like you said, you kind of graduated during a recession, and you were teaching and working in this fab lab, and this is just kind of snowballed, I think, like watching the stuff that you've done, whether it's Woods Baggett or WeWork or Boston Dynamics. It's you've kind of you went off on this path. Some people come back onto the architectural path, which is like there's lots of lanes there anyway. But it seems to me like you've just gone farther and farther down this country road that's kind of winding, and you kind of don't know where it's going next. So take us through a little bit of that.
Yeah, I mean, so I think I was at the Rapid Prototyping Center for about 3 years after graduating. So I stayed in Cincinnati for a while the economy recovered. But I was so dead set on living in New York. I had done an internship there working for KPF, and just like that's always where I wanted to live. And I'm still here for the time being. So I got an opportunity to go to City Tech. And City Tech is an architectural technology program, or was at the time. I think they're trying to evolve now. But it was differentiated from the City College School of Architecture, which is in Manhattan, because it was really focused on technology and alternative career paths. And that was really compelling to me. This idea that you didn't have to be kind of encumbered by, NCARB and accreditation and all that sort of thing. You could think like, what does, the education of an architect, I think, lends itself to all sorts of ways of, practicing in the world, but especially when you add technology onto that. So,
and when was this, by the way?
Yeah, so this was 2012.
Okay.
I moved to New York in January 2012. I remember getting out of the cab from the airport, and there was snow on the ground. And
welcome.
Yeah, exactly. And finding my out of season bed and breakfast in Ditmas Park, where I would stay for like 3 months while I found a real apartment. Shout out to Honey's Bed and Breakfast. So I was working there, and the cool thing was, first of all, it was like a National Science Foundation grant, and the grant had a lot of components to it. Shelley Smith and Ann Lenhart and the team there had worked really hard to win this massive grant for the school. And it really like fundamentally changed that school. And, a lot of really amazing students, I think, benefited from that at the time. And it was focused what appealed to me most was like, I would get to build a fab lab from scratch. So I would get the budget and the resources to do that, including my first robotic arm, which is like a gateway drug into robots.
Yeah, I bet.
Yeah. Can never get enough.
Right.
But also in the curriculum, we were creating these certificate programs. Again, we had like all this freedom to think about what this education could be. So there were 3 certificate programs. One was in computational fabrication. One was in sustainability and building performance. And then one was in BIM. And pretty much like everyone I know now in New York, like kind of passed through like teaching or participating or giving workshops or giving lectures. We brought in practitioners on a nearly like daily basis to do guest reviews and symposia and, really cool. Wanted to show, the students like, these are real technologies and like you can go work for, Situ, which has a fabrication shop in the Navy Yard, or you can go work for this solar analysis company doing energy modeling, or you can go work for this design technology team and think about facades, like, or you can be an architect, right? Like, whatever you want. And I think I'll kind of brush aside, there was the whole Fab Lab component to it, which, I think everybody kind of understands. But for me, the really fundamental thing that happened there were those 3 certificate programs and the way in which we kind of creatively blended them. So for example, there was a core seminar that was kind of the intro to computational fabrication where you learned about grasshoppers, CNC, 3D printing, etc. And then there was the kind of core like BIM course, and then there was a core like building analysis course. Well, all 3 of those courses had to work together as if they were a firm with different kind of specialized people on a team. And they had to use the analysis to drive the design. And then they had to kind of reconcile that with an existing condition model in BIM. And they had to make sure all of that worked together ultimately to represent their work, both kind of at the prototype and model scale, but also, as a set of deliverables out of Revit. So that was also like an aha moment for me too, whereas I had been super fixated on like free form geometry and modeling and fabrication. But that's where I learned about, analysis and simulation on one side. Mm-hmm. And then that's where I learned about BIM on the other. I've tried to avoid BIM as much as I can. I find it very boring. Yeah. But it is.
That's what the B is. That's what the B stands for.
It is a fundamental part of everything we do. So I was forced to start using that and would continue to use that at Woods Bagot. So that's where kind of this whole like simulation, analysis, design, fabrication, and documentation feedback loop. We were, with the help of our industry partners in particular, we were able to prove that out. Shane Berger, who is one of our industry advisors and runs the design technology team at Woods Bagot, then hired me. Okay. So after that, when that grant money was running out, I was like, okay, I think the economy is recovered enough that I can get back into architecture. And that's how I got into practice again with Shane at Woods Bagot. Yeah.
That's crazy. And when did you transition to Pratt? Was it after that?
Yeah, it was all kind of muddled together. It was like around the same time. I think I had set up the first like little baby robot arm at City Tech, and then Pratt had just purchased a few robots to set up in their lab at the School of Architecture. And I think it was something funny, like all these things work out. Like somebody on staff had finally left and like freed up a spot. And I had really wanted to work there because I've just always really admired the Pratt Institute. Mm-hmm. And I knew a lot of other people who taught there, and I had basically been like trying to teach there for a couple of years. And it's also New York, so you just work like 400 jobs at once. So it was like I was already teaching and working, but I was like, I want to teach more.
And you were a waiter, and you were,
I was a valet, honestly. But things were a little tough financially back then. I finally got into Pratt, helped set up that lab. I wrote the first industrial robotic arm course there. So now it wasn't just about making something ornamental with a machine driven by, some geometry model in CAD. Now we were actually using Grasshopper to run like structural analysis and environmental analysis on small structures where we could test those ideas physically with the industrial robotic arm. And the thing about the robotic arm that is, there are several things that are a little bit different from working with, these other types of machines is like, there are these kind of like very purpose-built machines like CNC machines and laser cutters, things like that. But when you have a robotic arm, you kind of have to invent everything. It's like, what is the end of arm tooling? What is the software that drives the process? What is your fixture and setup? What material are you trying to manipulate? And I really liked that. I liked how everything was kind of modularized and flexible. And you had to think through, it was both a materials problem and kind of a materials processing and tooling problem. And you could use parametric design in ways beyond just like the design of the pavilion, for example. It's like you could use a genetic algorithm to optimize like the fewest types of end effectors you would need to manipulate a wide variety of panel sizes or material shapes. So it became this game of like understanding the cost of variation, because I think students had been sold at the time. I kept talking about this myth of mass customization. And I'm like, that's not real. Everything has an expense. There is no like magic. There are technologies that have like made it a little bit easier to think that way, but everything has an expense. But if you have 1,000 different panel sizes and you're CNC milling their edges or you're laser cutting them, it's not really that much more expensive than having a bunch of identical pieces if you're using that same,
it just becomes
method.
A nesting issue, right? It's like, how many panels can you fit out of a bigger panel? Yeah.
With just like one more step in the algorithm, who cares? It's all like compiling at the same time through your, Grasshopper script or whatever you've set up. So no big deal. But then when you come to the robot and you have, 100 different panel sizes, it's going to be some kind of gripper problem, right? And we did not have machine vision at the time, which is a great solution to this problem. So we thought through it, the way we were used to thinking through it, which was like optimization and, things like Galapagos and similar types of tools, and just iterating a ton of solutions and finding the best one. K-means cluster algorithms, just ways to kind of say, okay, what can I do? Like if I only have 4 different, grippers that can hold this material, I've now constrained the area of the material that could be manipulated. So, we were doing things like heating and stretching thermoplastics over bucks. So, okay, now the area in which I could apply contact to the buck is now somewhat constrained, but I've lended some kind of optimization or efficiency to the tooling of the robot. So I like that you had to think through all of that stuff that is like fundamentally different than preparing models for production in like any other single manufacturing technology.
And kind of a sequencing thing too, right? Like there's the spatial requirements that a robot has, which is much larger than like a purpose-built CNC, right? Because you got the arm swinging around and different angles and things like that. But I would assume then too that the sequencing of can it get under the thing after you've done the over the thing part of it, right? And so you really have to think through so many layers of complexity there. You
disabuse them of the idea that it's also like this infinite build envelope around the robot. It's actually, you're still constrained. There are always constraints,
right.
But there are always opportunities within those constraints.
Yeah, this is why, like in Star Wars, like the drones just float through the air and they're very tiny and they can do things 360 all the way around them, right? Like that's the ultimate, the vision of where this could go. But right now, you're this thing is big. It's heavy. It's on the floor. It's got to be supported. It's got cantilevered weight. It's got there's so many requirements there. Yeah. I remember seeing Bjarka's proposal with Heatherwick to do the Google thing, and they had the idea of crabots, right? And it was like these.
Yeah. Whatever happened to that idea? That's like, I need to like find that again.
Yeah.
I forgot about that.
Crabots. That was a hot word around the studio for quite a while after that thing came out.
Also totally fake technology. Architects love to do that with, was it Wolf Pricks, who has like all these images of like robots on like scissor lifts. And I'm like, what? It's not a thing. Can't do that.
That doesn't seem odd at all. Yeah.
That's okay. Dream big,
Dream
architects. Dream
on.
big.
Yeah.
Yeah.
So, okay, so now what I'm thinking about is you've gone from tool user, right, back in the beginning to
Mm.
tool builder, right, which is like scripting and coding and things like that, to again like tool user, but actually having to design the pathways that the thing does, right? So it's interesting because like the tool pathing is another level. Like I've made tools before to make things in my
Yeah.
garage. And I think there's something incredibly satisfying about that in the real world. I also think there's something incredibly satisfying about building tools that other people use in the digital world. This is another
Yeah.
level because you're actually designing the thing so that the tool can do its job. I think that's a really interesting kind of layer of abstraction that not very many people think about because it's like the iPhone, right? Apple also went through, and any company, it doesn't matter, had to go through all of the work to design how the machine was going to make the new machine. Like they have to design all of that. I think that's really interesting as a conceptual thing.
Yeah, and I don't know if this is totally related, but it makes me think about, we've talked about, what medium you're designing in. And this was always a big conversation as we were figuring out how to educate architects at Pratt with David Erdman in particular, and also came up when Greg Lynn had visited and lectured there, and thinking about mediums as a framework or a platform. And, part of it is kind of like systems thinking. It runs the risk of like fetishizing, like you end up with students showing like a Grasshopper script or like the code.
Yeah.
But the idea is they are designing a system that can accommodate lots of ways of designing. They're no longer doing a drawing, they're designing the pencil, or they're no longer designing the pencil. They've set up a drawing implement factory or whatever, however meta you want to get. And I think that talking about this a lot with Andrew Human as well. I mean, PyPar is a platform for kind of democratizing this design intelligence in the form of like web distributed or cloud distributed algorithms. And jump cutting to Spot, it's this kind of platform for moving sensors through human purposed environments and bringing automation into environments that have traditionally been inhospitable. I knew I shouldn't try that word. Difficult, difficult to do.
Yeah, you said the magic word. I think it's a perfect segue because to me, the next level of kind of this path that you've charted is now you're part of a company that builds a platform, right? Spot, the robot, is a platform. And to me, again, like just to kind of go back to the Apple analogy of like the iPad, when Steve Jobs came out and showed it off, he's like, I don't know what you guys are going to do with this, but we can't wait to find out. Are you guys kind of taking that point of view with Spot? Because obviously you do have some ideas, and you guys have you've partnered with Trimble, you've partnered with several different people, and you've got a different payload attachments for Spot. But it also seems like sky's the limit. Like you tell us what cool things you can think about to do with this thing.
Yeah, I mean, if you take like the kind of the overall view of Boston Dynamics as a company, right? It started as the Leg Lab, founded by our now chairman Mark Raber, first at Carnegie Mellon and then over to MIT in the 80s. That spun out into Boston Dynamics. So there's been, like 30 to 40 years of kind of work that have gone into making legged machines that can actually function in the real world outside of the lab. When I was, and then of course the pressure to commercialize, moving from Google, where it was kind of research centric, to SoftBank, which is looking to get a return on investment. And of course, everybody wants the technology to be relevant and useful. So there was an initial process of discovery. And I remember I was at WeWork as a construction researcher, and about half of my time was spent thinking about industrialized construction and moving unitized and prefabricated construction offsite for efficiency, which is a really important thing to try to do. And then the other half was thinking about how to get better job site data to manage construction projects. We had acquired Field Lens, a construction management software
Yeah.
application, and we had acquired several general contracting arms who did not have great data when they came in. Like, many GCs suffer from this. So,
Yeah, it's a
we had a
messy
lot
process.
of,
That's a hard thing to do. Yeah.
it's so messy. I mean, so we're a data-driven company, or trying to be one at least, and we had supers and assistant supers on our sites going around with Ricoh Theta cameras, and then like figuring out how to upload that data to Field Lens. But it wasn't good enough, and it wasn't robust enough for the level of data capture we really needed, and the level of data capture required now to drive some more kind of advanced technologies, like anything CV model based or AI based that requires clean and consistent and large volumes of data. So, I was trying a bunch of different mobile robots, and it started like early on when I first joined in like 2017, of just kind of saying, okay, well, we know that we can't effectively fly drones indoors with like camera payloads, even though that's a really great way to capture data outside. And in my I don't have it anymore, but somewhere there's like an initial diagram that's like legged robots are too exotic for this, or it seemed to be.
Mm-hmm.
And I was like, okay, it's going to be wheeled or treaded. So let's test several types of these. And we did. And a shocker, they can't get very far on a construction site, whether it's from an obstacle, something on the floor, the stairs, anything, right?
Yeah.
These environments are so chaotic.
And they change all the time, right? So
yeah,
you kind of constantly have to adjust how to get over that obstacle. It's not going to be the same problem to be solved day after day. It's got to be different.
Yeah, absolutely. Like, and half the slab is flooded one day, and then, half the slab is for material staging the next day. And
Right.
it's just, it's pure chaos.
Yeah.
It's a great place to test robotic autonomy, because if you can do it there, you can do it anywhere, right? And then in 2018, I think it was the summer of 2018 or something like that, Boston Dynamics releases a video of spot robots moving around Japanese construction sites, and I lost my mind.
I saw that one. Yeah.
Yeah.
Going up and down the stairs, and
the day that video came out, I went to Dave Fano and everyone who would listen to me, and I was like, we got to do this. And we kind of talked about it a little bit, and it, or wait, am I remembering the story right? Yeah, no, that's right. I think we had kind of tried to look into it before, but without a lot of passion. And then this was the thing that really lit a fire under my ass. So we took a train up to Boston, and we talked to Rob Plater and Michael Perry. And I had my colleague, boss at the time, Tim Dumitrate, with me, and we signed on as a very, very pre-early adopter, and started testing Spot on our sites. And I was looking for three things. So I was like, can this robot navigate my site? Does it have the mobility to move through this site? Can it then do it autonomously? So is it repeatable? Can it capture data like 360 photographs, which is what's important to us at the time? We were also doing some laser scanning stuff. And can we take that data and use the Spot SDK as well as our own SDK for Field Lens to upload that data to Field Lens? And by the way, this was the third robotic integration I think we had done with Field Lens at the time. So shout out to that team for being so forward thinking, for what is now a much more common idea, I think, for autonomous data capture. So we were able to do all of that in basically a 2-week trial run. And there were some pitfalls and literal falls. But we did it, and I was like, oh my God, this is the future of bringing automation onto construction sites. This will substantially impact the way we do work in the field, and the ability to bring automation into a place that has been antagonistic to automation forever, right? So I was really excited about that. And it also kind of aligned with this other thing that I had been thinking about a lot, which is from the earliest days, I had been really excited about this linear design to delivery process. I am the master builder, and
yes,
all intelligence is contained within my, Grasshopper script, and I have overlooked nothing.
It's a modern Howard Rourke. Yeah, right there.
Yeah, exactly. Yeah. Oh, God. I admit to being interested in those things when I was 16, but I did get educated and move on. But there's a diss to the objectivists listening out there. Take that, Ayn Rand fans. Come at me on Twitter. But I really began to question that idea because at WeWork, we were, my God, I mean, for all of the distractions happening, that's kind of the level of Adam Newman and such. We were doing some really incredible things that, continue to be about 10 years ahead of where I think a lot of other people are right now. A lot of that was through vertical integration, and we were able to get to the point where bespoke design automation tools could deliver bespoke information to both our factory floor and our job sites. And we were really kind of closing the loop on all of that and getting really close, but there were still these, really kind of painful gaps. And a lot of those gaps had to do with the, intelligence and experience encapsulated in the subcontracted field trades, layout and carpentry and things like that. Things that are easy to overlook, but, absolutely critical to the successful delivery of any construction project. And I started to see that this kind of like macho, like we're just going to like force this process in a kind of one-way vector and like magically 3D print this building from this like, incredible BIM. I was like, it just doesn't work that way.
Mm-hmm.
There has got to be a feedback loop. There's got to be more access to real-time as-built field information for the designers to work off of. It was also very educational to work on construction projects that were being completed in like 3 to 4 months.
Yeah.
And working at this pace where it was like you'd get sales information and you'd start designing before demo even started. Like the lease wasn't even like, we had this really interesting system geared for speed where like you'd get to a certain gate where it's like there's a fair chance we might sign the lease, and it was like go, like start designing the building, use the automation tools, like lay it out relative to the floor plate, so eventually we'll get the as-built information, and at that time we'll just be correcting the model to that. And that was really cool to see, but there were still gaps in the effectiveness of that, and part of it was just like we need a constant stream of data from the field being served up to the designers. This became like very apparent in COVID when it's like, oh, sorry, architects doing CA work, like now you can barely get on site. But just the idea that anyone could have virtual access and eyes on site for this remote data, and that you could have real-time as-built information, or at least the data coming in, not necessarily the technology to properly ingest and process.
It's a huge amount as well, right? I mean,
it's too much. There aren't many tools for it. That's why I'm very bullish about things like Avere. Also some ex-We workers there. Shout out to them. But so yeah, like it really became about like my whole career up until this point has really been about driving the influence of the designer by virtue of a data-rich model further and further and further into the process and have more and more control in theory. This is before I learned about, contracts and such and architectural practice, and then, was humbled several times over, and then realized like one is like, I have to get out of the design bid build world. There has to be an entrepreneurial business model that lets me experiment. So that's like leaving traditional architecture practice for WeWork. And then two is like, there has to be, it's like, no matter how vertically integrated you are, if you don't establish some kind of robust like data capture program and feedback program into the design and documentation process, you're really gonna miss out. You're gonna fail in certain ways. And for me, the way to have the most impact in that respect was to join the team of Boston Dynamics, was to like try to contribute very directly to the success of this new breed of robot, specifically on job sites.
And you guys did have a reality capture team, but they can only be in one place at one time, or, however big that team is. Were they excited about the possibility of this as augmenting their team or the, the company at large, or were they more about, I would imagine, I'm speculating here, but like contractors are very kind of like, what's that thing doing on my job site? I could imagine there could be some of that too from a team whose livelihood could be kind of, impacted
for
by
sure.
this.
I mean, we had those conversations up front, and one of the nice things about moving from architecture practice to WeWork was I no longer had to argue about the value of technology. It was assumed at WeWork that you would be throwing every bit of technology at the problem. And also we were doing, before the bad times came, I mean, the work we were doing was doubling year over year. And it was like you had to adapt each year and adopt new technologies, or else there was just it wasn't
couldn't keep up.
feasible to
Yeah,
deliver. Yeah, it's crazy.
absolutely. Yeah.
Can't believe we did what we did in retrospect. But yeah, we had those conversations with the scanning team, but the scanning team is also, again, talking about, the intelligence of kind of each specialist. Like they knew that just capturing all of that data wasn't the whole story.
Yeah.
And this is something I am still directly contending with. They were like, okay, well, you can capture all the scans and you can automate that. No one's going to. We talked about this with Adam Davis and Martha at Foster and Partners on their applied research and development team, and they're talking about like no one thinks that like using a robot to scan a building one time is faster or easier than sending people in.
Mm-hmm.
The point of it is the repetition. The point is that you want this information on a kind of daily basis. And you can do that with Spot. You can operationalize Spot in that way, and you can get that data on a daily basis. But what do you do with all of it? It's like, oops, we solved that problem. Now what do we do with all of that data? Because
if you collect it, it's not enough. You just can't
yeah. You have to register it, right? Mm-hmm. So there is some post-processing there. I mean, those algorithms are getting faster. You can do that in the field. Like, the Trimble FieldLink app, I can download the data from Spot and I can register it right then and there. Mm-hmm. There are continuously registering devices that are slightly less accuracy, but they give you the registered cloud as the output. Like, less worried about that part. Mm-hmm. More worried about what are you doing with that data, right? So, what is the point of all of this? At WeWork, we were making sure that our EC models were correct, so we weren't putting the desk in the middle of a column because a desk was our financial unit. Mm-hmm. You lose a desk, you lose a lot of money.
Right.
And, there are different ways of looking at that in similar types of design processes. So, you'd bring in the point cloud, you'd import it into Revit. It would be heavy and hard to view. Mm-hmm. You'd basically be viewing it like superimposed onto your Revit model.
Yep.
And then you just nudge things, right? Oh, okay, the column is an inch off, I'll nudge that over. The wall's a little bit off, I'll nudge that over. And you can't do that every day. And there's nowhere to like store it, and it's hard to view. And so there are all these issues. So it's kind of like, okay, well, what are you trying to do if you're doing it on a daily basis? Well, you're trying to understand what's been placed and if it's been placed correctly. Mm-hmm. And then you can use that information to do all sorts of other things. You can sequence people on site in a more efficient way so they're not wasting time. You can stage the site ahead of time for those trades. You can automate payments to subs based on work complete. Right. There are all sorts of things you can do. That's where you start to get into the actual ROI calculations. But first, you just need to say, like, yes, this thing has been placed, and yes, it was placed in the correct spot. There's nothing unexpected. So really what you care about is not all of these point clouds, which are like kind of cool the first couple times, but then you get sick of them and they're big and unwieldy. It's like you care about a report that gives you pertinent information. So I mentioned a veer, that's the point of that, right? Is to associate, the portions of point clouds with their respective like Revit or Navisworks elements, and then to say like, yes, I can verify that this has been placed, but hey, by the way, it's like 2 inches off. Is that a big deal? Bring that stuff to your attention. So
hopefully, you can be a little proactive about the RFIs that are coming, right?
Yes. And then you just have like a dashboard of like what's going on your project. It's a small thing, right? Like what's going on, but it's really hard to know. And you spend a lot of extra time figuring out what's going on. And like most projects don't get delivered on time. Yeah. And so it's just any improvement you can make to the management of that is going to help you beat that.
I could see architects still being kind of like, what's the point? Because like most architects aren't responsible for as-built drawings, right? So, or as-built models, and they're not. It's so interesting to me to kind of watch practice and how little value someone's time holds. So it's like, they can do CA, they can do change orders, they can do RFIs all day. If it's just not something that's really taken a huge. There's not a lot of respect paid towards people's time still. In the profession.
It would fix the architecture industry overnight if you could only pay your employees hourly, but let's not get into that. So labor is cheap. This is why I don't fixate on the value of automation in terms of labor hours. Labor is very cheap, whether it's on the design side or the construction side.
But I can see why you guys are really honing in on construction. Like that's your job, right? Is to talk to construction people. And it seems to me like there's a huge amount of value that they can, it directly attribute to the bottom line immediately.
Yes, it's the general contractor is the one who's ultimately responsible for delivering that project on time and for doing the handoff to the owner. It is a world of conflicting incentives. The idea is to try to raise the C-level for everyone involved and make sure that we can get some more alignment there, whether it's through risk sharing or just market pressure where enough subs are doing the right thing that the other subs kind of have to go along with it. But the truth is that I might be a sub who makes money off of underbidding and change ordering to death.
Yeah.
And that's like actually my business model. And I am incentivized by the market to operate that way. So I feel very fortunate that we have a robot that is of direct benefit to the GC, because I feel like the incentive and the opportunity is a lot more obvious.
Create some accountability. Yeah.
Yeah. And it creates conversation overall too with the trades on site and with the architect. I still hold architecture near and dear to my heart. I'm very critical of the way that it's practiced and, try to be creative in ways of making that better. It was really great to work with Foster and Partners in that respect. There are some opportunities there. It's a question like, do you want to get in the business of better as-built? Do you want to be involved in the handoff? What services could you offer with respect to better remote CA, digital twin type models that are augmented both kind of in 4 dimensions and with like sensor information on top of geometric information and typical metadata, materials tag tracking with RFID, blah, 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 blah. It very much makes the most sense for the GC. I'm not arguing that, but what I'm saying to architects is like, do you want to get in on this a little bit, or you just
want to be ready when it becomes normal?
Yeah, or do you want to keep playing with robot arms in your Pratt course taught by Brian? I feel like I've contributed a little bit to some of the to some of the distractions in the way that I think the architecture world sees robotics again as a means to extend design intent through direct, file to machine control, model driven delivery, but that's not really the way that delivery works. I think architects are going to be best suited to think about what would it mean for my design and documentation process if it were augmented by real-time construction site information. Are there services I could build around that? Or at the very least, could I make more profit when I bill for this? I mean, again, like there isn't a huge amount of pressure on architects for, opinion here, right? Like there's not as much pressure as there should be to deliver more efficiently because so many architects are underpaid, severely underpaid. You also asked me like, some people come back into architecture after trying different things. Like, I don't want to go back to that lifestyle. I felt like it was abusive. And I'm not, not to generalize. There are some really forward-thinking practices out of there that kind of respect their employees' time, but it's easy when you're under pressure to fall back into these old patterns of working, 80 hours a week, but being paid for 40. And at least track that internally, like at least like do a speculative exercise on like, how much would this have actually cost us, and understand how unsustainable.
Everybody's time card is fiction, man. Everybody.
Yeah. And then, the architects go, protesting to Autodesk about charging them too much for Revit. And I'm like, well, okay, but, look inward a little bit too, maybe. Like, I think it's a much bigger and deeper conversation that is fundamental to the way these businesses are run. So again, like, can you optimize your time better? Can you better leverage? I mean, architecture is such a human resource driven business, right? Yeah. It's all about the time and talent of these designers. Can you actually make their lives easier by giving them better data to design to? Like, why am I waiting for an RFI like 3 months later?
Right.
Like, what is that? That's a very strange process.
It's a very reactive
I understand why it is the way it is because of contracts, risk, blah, blah, blah. But let's question that.
Yeah. Okay, so how do you get more of these robots into? You want to attract architects to this. You want to have them become early adopters. I'm sure there are some, but what does it take to get into to having a spot, walking around the firm, so that it can actually be the thing that we put out on the job site?
Yeah, I mean, I think in all practicality, it's about finding architects who have strong relationships with GCs. because they're going to learn
It has
from
to
the
be a
GCs
partnership.
first and foremost.
Yeah.
Yeah, because the GC is the one who's incentivized to purchase the robot, to manage and own the robot. But if you have that relationship with them, you can at least get an idea of the types of data that you could be pulling from that.
Mm-hmm.
And one could imagine if a robot is remotely a remotely accessible, walking computer on site, like I, the architect stakeholder, could log into it and go look at something I need to go look at. And then I could, turn that control. We call it hijacking the robot. This is an actual feature. Like you can kind of trade off who is controlling the robot. But I recognize that it's difficult to share equipment, things like that. But I think, like with everything else, it would take a kind of shared risk and collaborative approach with
Mm-hmm.
another stakeholder to truly benefit from that. Now, that said, these robots aren't so expensive,
Mm-hmm.
right? The base cost of a spot is 74.5, and yeah, there are bells and whistles on it that could take it up to six figures. It's a lot of money for some firms, but there's some large firms out there that could see that as a reasonable investment,
Mm-hmm.
particularly because that is a one-time cost,
Mm-hmm.
and now you can get recurring revenue through the services that are offered through that robot. So can you pass that along with billing? Now, this is challenging.
And the potential
practice,
savings, right? Based on the things that you're saying. Yeah.
Yes, potential savings, but also architects are like, can I bill for this?
Right.
Because we tend to get caught in this bizarre loop. I saw this when I was on the design technology team at Woods Bagot, where it's like, now we're augmenting our design process with design automation, but we're not charging for that. Now we're augmenting it with augmented reality and providing like apps and experiences for the client, and you're still not really charging for that. And and it's like architects are so inventive and innovative, and they're always bringing in new technology, and they're always kind of improving like the delivery, but it just seems to manifest itself in like more work you're doing for the same or less amount of money as like margins continue to get shaved away. So that's kind of the question. I don't have a great answer for that, but like, a way of how do you impose your will in those situations to demonstrate that, hey, there is enough additional value here that this is something I can bill for. How do you convince everyone? How do you convince an owner that I'm going to give you a completely 100% accurate handoff? How do you convince them that that's important? They would have had to have gone through some bad handoffs in the past to be like, yes, if you can guarantee that, please.
Right.
And I think part of the issue, and I think I saw this in my time in architecture, is it's hard to build lasting relationships because, again, of the way like design bid build manifests itself in these different stakeholder teams. Every time you do a new project, you might be working with a new structural engineer.
Yeah. Rebuild trust. Yeah.
Yeah. And so it's hard to really like build the same way. It's hard to learn from each building product because they change so much. It's hard to build those kind of, like what you said, build trust and build off of that and find better ways to collaborate and kind of learn together and understand what's valuable and what's not. It's kind of like, what's the baseline? It's hard to keep track of the baseline because every parameter changes from one project to the next. It is a sticky problem.
So what's next for Spot? I mean, you guys have payload options, things like that. Where obviously there's tons of training going on. You're trying to get it on more job sites. What's the short term?
Yeah. So, I mean, this year was all about, the early adopter program for me, working with, a couple dozen GCs and some developers in the AEC space. And, on the side of the end operators of the GCs, understanding the robot's performance in their environment, the robot autonomy performance as that environment changes, and also their operational concerns about, security and managing the robot on the site, all those little things that are required for that to deliver reasonable value to them to keep working with the robot. And, some things are a no-brainer. It's like the mobility is always a home run. Other things like, can I secure this robot at the site overnight? And can it be self-charging? Those solutions are coming next. So in the new year, we will be offering, it's actually available for sale now, if people want to pre-order it, but we'll be offering a self-charging dock. And, one thing that means is there is no more kind of limit on, there was always this kind of hard 90-minute limit. Like I have to go in, I have to intervene as a user, and I have to swap out the battery. So even if I can go do something for an hour and a half and come back, which is valuable, really what I want is a robot that's just like always doing stuff without my direct involvement, but just my passive supervision. So, the dock gets you that, but I think more importantly is it gives you a robot that's always on. This robot is always just sitting there powered on, waiting for instruction. Mm-hmm. So if I want to, again, I'm an architect and I'm working with the GC and I have access to this thing and I have a network connection to the robot and I just really need to see something like, has the plumbing gone up, in this wet wall yet? And, when can I expect to start drywalling? All sorts of questions you might ask. Did this thing get placed correctly? And you could just kind of teleoperate the robot. Just take it over there, get a look. Or you're running, scheduled and repeatable missions, which is like every morning I'm going to scan and every evening I'm going to, do my job walk with 360 photos. So the dock is a fundamental kind of hardware shift that will extend autonomy in a lot of really interesting ways. And I think it gets us toward this. For me, the end game is, I don't think a construction site will ever be lights out the way that is easier to imagine for like factories and warehouses and logistics. But I do think you could have a lights out shift. Mm. And I think it could be a very symbiotic relationship between human workers and the robots. And it's going to be Spot and like several other types of robots. Spot's not going to be purpose built for like every little thing. I think there will be just as many types of robots and machines on site as there are types of people doing different work on site. So all of that could happen primarily overnight, assuming you're not running 3 shifts of construction. This does happen sometimes. Yeah. But we're assuming there's an open night shift, and then the robots are doing a lot of the heavy lifting in that. And what they're doing is they're taking a snapshot of the exact condition. They're feeding that into all of your digital systems that, get you ready for the next day. So you can basically get, here's my list of orders for the day based on what was done yesterday. I don't have to put a lot of like time or effort into preparing that information, which is a huge part of like a super or PM's job. And I can just get to work right away, and I can do that work. And, that might be augmented or assisted by robots during the day, but then, rinse and repeat. And, with the addition of the arm, we're even starting to look into, the arm for me is most obviously valuable.
Freaky.
Going into hazardous environments. It's freaky. Yeah. It scares people a little bit, but yeah, I think you can go into hazardous environments. You can flip switches, you can press buttons. It's really important for industrial customers. In construction, there are all sorts of future applications, that involve manipulation or even marking and layout. But like, I like the idea that you could do a little bit of like staging, move some things out of the way. It's got
you can go through closed doors, right? I mean, that's one of the,
Yeah, so just like stairs were really important. Again, you have to take these challenges head on. You can't like pretend they don't exist. So, okay, I need a robot that can go into a building. All right, well, it needs to go up and down stairs. So, okay, we solved that. We're continuing to make that better. What's the next thing? Doors, right? Yeah. So that was the origin of the arm's been around just as long as the Spot project, really, and was originally conceived to be able to pull open the door and move through that. So, I always joke, you can still lock your doors. So as long as you don't buy the lock picking package from Boston Dynamics, you should be okay.
That's awesome.
But yeah, so, I focus more on the self-charging aspect than the arm aspect for the construction customers, just because I like to be very deliberate about like, this is the next thing that
it's really practical. Yeah.
Yeah. We have to be practical with this. It's so easy. I've worked in an innovation group. I work with lots of innovation groups. It's so easy for them to cycle through all the latest and greatest technologies and to not see like a meaningful impact on their work. Just be, okay, that was cool. I did a little VR, I did a little bit of this, a little bit of that, but like, it doesn't really, impact the workers in the field. Like, we need to focus on what's practical and what's impactful. And we need to stay humble about, I was hired because of my expertise in construction, but, I try to be on sites. It's hard with COVID, but I try to be on sites as much as possible because, we're learning everything from the customer in terms of how to make this more valuable.
Well, I have to say you're a little late to the game with the charging, because like the only robot that I own is my Roomba in the kitchen, and it's had that for a while.
Yeah, you would not believe, yes, and good like cliff avoidance and things like that. You would not believe the amount of times I've been challenged based on the functionality of a Roomba.
Yeah.
And so first and foremost, the Roomba is an incredible product.
It is.
There are very few robotic products that have survived. Like 99.9% of them all fail. And they're, the Roomba is like one of the best examples. There's like drones in construction, maybe like the Sony Aibo or the Husqvarna Automower, but like the Roomba is like the gold standard for like a useful, functional robot product. It's purpose built. It's not too fancy. It's got just the right amount of technology.
It does
solves
the
the
thing.
Problems.
Yeah.
It's a great story. Like there's so much fascinating reading about the fact that like, I don't know if it uses suction now, but like the fact that it like didn't use suction originally, it turned out that wasn't needed. It's such a great story. And I think there's a lot to learn from that. So I try not to get too defensive when people are like, why is this little robot vacuum, able to do these things? And I'm like, well, can it walk up and down stairs? I'll get like super, can you flip it over on its back and have it, flip itself right side up? When I was a customer in 2018, 2019, I was like, I need self-charging. But I get it. When we solve a problem, it has to work with a complicated machine, with a legged robot. It has to be robust. It has to it can't just work some of the time. It has to work all of the time.
Mm-hmm.
And it has to be in really, really challenging environments. So the IP rating needs to make sense. You have to be able to drop it. You have to be able to have the robot crash into it 1,000 times. It's tough. It's a tough engineering job, but luckily I work with, some of the most brilliant people in the world, and we solve that bit by bit by bit, and we march onward.
So you said that the Roomba is one of your favorite things, and I think this wouldn't be a holiday extravaganza show without a final quick segment. I really appreciate your time. So you like the Roomba? Obviously, cats can ride Roombas. Maybe cats someday will ride Spots. But
I like where you're going,
and I love how you kind of collect. I only know this by following your Instagram stories, like all of the crazy stuff that's going on in robotics. Like I think you talked about this kind of robotic fetishness. Like that to me is, there's so much cool stuff there. It's just fun to look at and fun to follow along.
Yeah.
What is your favorite movie robot of all time? So final holiday extravaganza question for Brian Ringley.
Man. Joe, that is such a tough one.
Let me throw some out here. So obviously there's the Star Wars series, right? You got the BB-8s, you've got the R2-D2s, the C-3POs, but then there's like the Terminator, right? I think, now I'm going to hold this one back because you might say this one. Iron Giant, right? The HAL 9000, that minimal robot, right?
Classic. Yeah.
So I'm holding one back because I think you might say it, and I'm going to let you say it if it's true, but go for it.
Does TV count too?
Sure.
Or does it need to be? Okay. I'll talk about the two robots that made me jump up and scream on TV, which was in the beginning of season 2 of Westworld, when there was this kind of humanoid bipedal construction robot. If you watch what it does, it's climbing the side of a building and running a piece of cable up the side. I'm not quite sure what it's doing there. And it also died, spoiler, it dies too young. So that one made me kind of shout and stand up, because there were a few funny things about it. I'm always thinking about how do you secure a robot on site overnight, and what is the concept of operations for that? And the character just comes in and unchains it with a padlock. It's just chained to a column or something.
Yes.
And just starts using it as a companion. So that got me super excited, because how often are there construction robots in popular culture?
Mm-hmm.
But the other one was much more recent. I was watching The Mandalorian. Have you been watching that?
Yes, I have. It's a family thing right now for sure.
Yeah, so there's that scene where they're landing and the ship tips over and falls underwater, and in the next scene it cuts to this giant four-legged crane.
Yes.
Walking through the water and lifting this thing out, and I was like, this is so awesome. This is the coolest thing. I want a Spot that's that big.
So yeah, I mean, we want the whole spectrum of sizes of Spot. We want Chihuahua Spot, and we also want but yes, less yappy, right? We want, but we also want ginormous spot as well.
That's right. Yeah. So I think those are the two like of late that like really got me pumped up.
I thought for sure you would say Ava from Ex Machina.
I
more android than robot, maybe. I don't know.
I thought about Ava. There's something really interesting about how manipulative she was, and the idea of not just how like intelligence needs a physical embodiment, but also like how sexuality is a form of intelligence. Like, but by the same token, it was kind of this like hyper male fantasy movie.
Yeah,
that was,
totally.
like, slightly problematic. So I chose not to go with that one. There are some interesting. Here's what I do love is when she knifes the guy. That's a pretty badass scene.
That was crazy.
Two like robots work together to knife the guy.
Jaw dropped. It's like it's over? What?
Yeah. And I love how they just the other dudes just like left locked in the room. There is something like it's so many spoilers.
Let this be a lesson to you, humans.
Yeah, it was that was like there was something a little bit satisfying about that. But yeah, that movie I don't think ages super well, I'm afraid.
Yeah, and it's not as fun as an R2D2 or a BB-8 or whatever.
So. Not quite. Yeah. And it's also just like it's technologically preposterous too, but suspension of disbelief and such.
Exactly. Well, it's entertainment. Yeah. Well, thank you so much for spending your time. I would love it if you could just drop some links here on people. Where can they find you, follow you on Twitter, Boston Dynamics, etc.?
Yes, I'm pretty easy to find. My name, Brian Ringley, all one word, on Twitter, on Instagram. I'm on LinkedIn. You can contact me, for business things through the Boston Dynamics contact form, or you can shoot me a message on LinkedIn, or you can see my weird robot fetish posts of, Furby and how much people love their auto mowers, which, by the way, the auto mower thing that I love so much, like, not to digress, is this emphasis on like the leisure of automation.
Yes.
Like This is
what the promise of it has always been, right? Like,
and for some reason that story is so easy to craft when it's lawn work, but so hard to craft elsewhere. Elsewhere it becomes this kind of problematic but important discussion about like job loss and things like that. But when it comes to, and this is it, right, the uncompensated domestic labor at home,
Rosie the robot from the Jetsons, man.
So the Roomba, the auto mower. I mean, I think it's really clever. And I think hugely promising, and we'll see a lot more there. I live in Brooklyn, so I have no space for an auto mower and no lawn to speak of. Mow, but drones are illegal here too. I've got to move to the country. I feel like you can't fully like embrace robots in Brooklyn. I'm afraid.
You need acreage. Yeah. I mean, and in California, like lawns are illegal. So you can't do it. Well, I appreciate that digression. So thank you so much for spending the time with us today. It's been a fantastic conversation.
Yeah. Thanks for having me. This is great.
Hey listeners, before you turn this thing off, I wanted to say thank you for 6 great months of podcasting. I've made this show for you, and I truly hope that you're enjoying it as much as I am. I think this type of open conversation is valuable to the AEC community, especially with how technology is rapidly changing it, which is obviously the whole premise. Holiday breaks are a great time to catch up on previous episodes, so head over to trxl.co/podcast or to gablemedia.com. That's GABLMEDIA.com. It's Gable without the E. Of course, you can simply search in your favorite podcast player for TRXL. I encourage you to subscribe to the show, and please share it with somebody. That would really help me, it would help the show, and it would really help the Gable Media Network. So I appreciate that if you would do that right now. And lastly, I have to say that one of the inspirations for this show, among many, was Zach Downey's and Brian Ringley's Designalize podcast, which I've included a link to in the show notes. They haven't recorded an episode in quite a while. Brian did mention it also during the conversation. He said that they've got some that they just might release someday. So hit him up on Twitter. Again, links to his Twitter and everything are in the show notes, and let him know that you want to hear that. So that's it for 2020. I'm really excited about 2021. I already have some great episodes recorded and queued up, which will be coming to your ears very soon. So with that, I'm signing off. Once again, thank you so much for listening to this podcast. I could not and I would not do it if you weren't there. So thanks. I'll talk to you soon in 2021.